Hi, this is Mrs. Secor, and I just want to help you have a few flashcards kind of in this notebook form to help you study for the night of the OGT. So, one thing we do need to know is how the number system looks, the different kinds of types of numbers. The one that goes in the smallest circle, those are natural numbers. And those start with 1, 2, 3. Then we can add our 0, and that becomes the whole numbers, including the natural. And then the integers, going negative. Okay, and then the rational numbers, which include fractions and decimals and repeating decimals. All right, and those are rational, and on this side are irrational. The most famous one is pi. Doesn't end, doesn't repeat. Radical 2 doesn't, radical 5 doesn't. There's some others. And this whole system, rational and irrational, make up the real number system. Okay. Absolute value. Anything in absolute value is always positive. So if it's negative 2, pops out positive. If it's positive 2, pops out positive. There's 4 fractions that I'd kind of like for you to make sure you know. 1/4, 3/4, 1/3, 2/3. Now to change a fraction to a decimal, you simply divide the numerator by the denominator, and you would get in the calculator 0.25. To change this to a percent, you move the decimal over 2 places and add a percent sign. 3/4, 0.75, 75%. 1/3, 0.3, you'll see it repeating. You can write it like this, 33 1/3%, or 33.3 with a bar over percent. And 2/3 is 0.6, repeating, or 66 2/3%. The next section is powers. Anything to the 0 power is 1. 8 to the first power is just 8. 8 squared means 8 times 8, which is 64. And 8 to the third is 8 times 8 times 8, which is 512. And you could use that caret key on the calculator. Make it 8 to the third. Okay, scientific notation will definitely be on there. We want to move our decimal point back so it's a number between 1 and 10, so it'll be 2.5 times 10, and we moved it back 6 places. Okay, this one we're going to move back 4, so it'll be 3.2 times 10 to the 4th power. Here, this is scientific notation. If we want to change it to standard, the 8 will count as one place, so we'll have to add 4 more zeros. 4, 8, and then 4 zeros. Go back, put our commas, 480,000. Small numbers. We want to again make it be a number between 1 and 10. We've moved the decimal 3 places back, 10, and then it'd be negative 3. Place value. All right, here's our decimal point: ones, tens, hundreds, thousands, 10,000, 100,000, and then million. Just make sure you know how to round this number to the nearest. Okay, 10,000. The digit in the 10,000 is 5. Check the digit to the right. If it's 5 or greater, it rounds up. So then number would be 1,360,000. Whole number, okay? Whole number is the same thing as 1. So it'd be 1,357,920. To the nearest tenth, we want one number, one digit in the tenth place. So we have 1,357,920.6 is going to make this bump up to 5. And hundredths, the 8 will force the 6 to bump up. So it's 1,357,920 and 47 hundredths. Okay. Exponent operations, the damp SNAM. Okay, so if we multiply, we add. So we have x, we add the 3 and the 4. If we divide, we subtract the exponents. 6 minus 4, x squared. Okay, when we are adding, this would really be a 2 and a -7, because for add and subtract, we do nothing. See how the exponents, the variables here do match. We do this operation though, a 2 and a -7 would give me -5, but then I can write my x to the 5th y. Okay? Here I cannot combine the 2 and the 7 here because you see how the variables don't match? They did here, so I could combine those, but not here. So this just stays the same. 2x to the 5th y minus 7x to the 3rd. And here we have powers to powers, and when we have that, we multiply. Okay, so 2 to the 5th, 2 to the 5th power is 32, okay? And then x to the 3rd, 3 times 5, 15. And y, multiply the powers, 20. Let's go out to the calculator just for a minute and see how we could put that in. I know mine's different, but your key is close in the same place. We'd hit 2, the caret key, two, caret key. I don't know why that's not working. All right, forget it. All right, sorry. Okay, so 2 to the 5th power does equal 32. Next page. All right, some discounts. There will be one like this on the test. Megan wants to buy a mirror for her room that is usually priced at $85 and is now discounted by 40%. What is the sale price of the mirror? What we're going to do is we want to have the original price, and then we want to subtract the discount. Okay, original price, $85. Discount, $85 times 0.40. 40% of, so you multiply. If you multiply that out, you get $34. Okay, so we subtract 85 minus 34, and we end up with $51. That's the sales price. Sales tax. Here we want to add when we have sales tax. Gail works in a small hardware store where the cash register does not compute the sales tax. If the sales tax is 7%, what amount should she add to her purchase of $10? Okay, so we want 7%. or 0.07, right, times 10. And that gives me 70 cents. That's the amount she's going to add. Her sales tax is 70%, so the price would be $10.70. Probability. The probability of spinning a 3 is 1 out of 4. Justine has a bag of 20 marbles. 10 are white, 3 are green, 2 are blue, 5 are yellow. In the bag then, gives me 10 down here, so we have 20 marbles. What's the probability that she will pull out a yellow marble? 5 out of 20. Always reduce. Divide numerator by 5 and denominator by 5, 1/4. There are 10 straws in a box. Some are white, some are red. The probability of reaching into the box and selecting a white straw is 2/5. Pull out a white. How many red straws are in the box? Well, if the white's 2/5, the red is 3/5, right? 3/5 of 10. 3/5 times 10. If you want decimals, you can. It means to multiply. You could say 0.6 times 10. So then I just would move my decimal over. There must be 6 red straws, and then there are 4 white ones. A tree diagram. Susan has a choice of a tan blazer, a blue blazer. She can wear tan, blue, or black pants. How many combinations of blazer and pants does Susan have? If they ask you to make a tree diagram, you do start out with, okay, so tan pants or blue, blazer. Tan blazer, blue blazer. Now the pants. They come in tan, blue, or black. Tan, blue, black. Tan, blue, black. I think I have seen that on there before where they ask you to do a tree diagram. Fundamental counting principle. Okay, we've been working with this. There are 2 events. One, you choose a blazer. There's 2 outcomes. The second thing, you choose a pair of pants. There are 3. So the total outcomes is 6. Blazers, 2 times 3 pants is 6. And you can see them here. 1, 2, 3, 4, 5, 6. Okay, measures of central tendency. That's your mean, median, modem, range. Okay, the mean. Add them up. Let's see, I think that's 30. Divide by how many there are. 1, 2, 3, 4, 5. The mean is 6. You can see it. Would be 6. The median, you have to get them in order first. I like to put blanks so I don't mess up. There's 5 of them, so it'd be 4, 6, 8, 12, 20. The median is 8. The mode, that's the most common. There are 2 88s. 88 is the mode. The range, highest minus the smallest. Highest is 110. Smallest is 42. 110 minus 42. Let's see. What is that? Goodness. 8. 68. 68 is the range. Sorry about that. And if the mean number of people who attended amusement park over 5 days is 25,000, what was the total attendance? during the 5 days.